Okay, welcome. In this video, I'm going to be giving you a brief introduction to the unit circle as a way to wrap up our, foray into trigonometry as we end Algebra 2. Okay, and the unit circle is something you're really going to need to know in pre-cal, and we are not trying to bite this all off right now. We're just going to kind of start in on it and see where this is headed. Now, I want to start by talking about the virtues of a right triangle that has hypotenuse with length 1. Okay, so if we go and just talk about sine and cosine of theta, and we go and think to ourselves on a SOHCAHTOA level, sine of theta is equal to the opposite leg divided by the hypotenuse, which is going to be y divided by that 1. We know how to divide by 1. That doesn't really do anything. So sine of theta would just equal y. And the same thing would happen with cosine of theta, because cosine's adjacent over hypotenuse. Cosine of theta would just be x. So if the hypotenuse of a right triangle is 1, then the side lengths themselves are the values of sine and cosine. And next I want to take you back to this diagram we drew in the last video when we first started talking about radians. Okay, where we had kind of like divided the circle up into these like common places. And maybe you noticed that probably the reason that I had 30, 45, 60, 90, 180, and 360 is that they all kind of relate to the special right triangles that we've got. Okay, our 30, 60, 90 and our 45, 45, 90 triangle. Now the, 0, 90 degrees, pi over 2, 180 degrees, 360 degrees, you might be sitting there saying, like, okay, what are we going to do with that? But I'll show you what we're going to do with that. Okay, so I'm going to just start with pi over 6. Okay, the nice thing about the unit circle is that we're going to assume that this circle has radius 1. So we're going to be able to, use that same thing where the side lengths will give us the values of sine and cosine. And at pi over 6, that's going to make us a 30, 60, 90 triangle. Okay, where this is the 30-degree angle. Okay, now we're getting to a point where we're going to start moving away from degrees as a way to measure our angles, but for now I think it'd be all right. Okay, now if we know that this is side length 1, okay, then we know that the short leg is half the hypotenuse. So that vertical side, that's going to be 1/2. And the longer leg is we take the shorter leg and we multiply it by square root of 3. So 1/2 times the square root of 3, that would be square root of 3 divided by 2. And so what we're going to say is, okay, well now we know that sine of 30 degrees, opposite over hypotenuse, that's 1/2 over 1. And cosine is root 3 over 2 divided by 1. Okay, cosine of 30 degrees is root 3 over 2. And that's great. But what we're going to say is, okay, that now the coordinates of this point on the unit circle that corresponds to the angle pi over 6, the coordinates of that point are going to be root 3 over 2 and 1/2. Okay, for pi over 4, we're going to do the exact same thing. We're going to draw in a little triangle. And this is still going to be my recommendation to you in pre-cal class when you're having trouble evaluating, like, cosine of pi over 4 or something. You draw a triangle. Draw a circle, draw a triangle. Okay, but I'm going to actually bring this out a little bit because, okay, at pi over 4, that's a 45-degree angle. We're working with a 45, 45, 90 triangle. And, that was where we started with all this stuff, was with the special right triangle, so you should be pretty familiar here. Okay, now the issue was that we knew what to do if this was x, right? Then this was x times the square root of 2 over here. But now we've got side length, or hypotenuse, 1. So to go from, leg to hypotenuse, we multiply by square root of 2. To go from hypotenuse to leg, we're going to divide by the square root of 2. And that means this one's also going to be the same because 45, 45, 90. The thing is, we're not going to write this as 1 over square root of 2. We probably need to recognize that it's a number that's equivalent to that, but what we're going to do is rationalize the denominator, and we're going to call this root 2 over 2. Okay? So the coordinates of this point, I went to the right by root 2 over 2 because of the width of this triangle being root 2 over 2. We went up by root 2 over 2. So I'm going to say that at the point where theta equals pi over 4, the coordinates on the unit circle are going to be x equals root 2 over 2 and y equals root 2 over 2. At x equals pi over 3, exact same thing, but I'm going to still draw the triangle for you, even though you might be able to figure out what the coordinates are going to be at that point that I've marked in orange. Go in here, it's going to be another 30, 60, 90 triangle, except this one is going to be, I guess, a 60, 30, 90 triangle. And I'm not as good at drawing these, but I think this looks pretty good to me. Okay, we know this is a right angle, this is the 60, and that's the 30. Okay, so again, hypotenuse is 1. The short leg on a 30, 60, 90 is half the length of the hypotenuse, so that's a half. And the longer leg is the shorter leg multiplied by the square root of 3, so this one's going to be root 3 over 2. So I can see that on this triangle, the height is root 3 over 2, the width is 1/2, so the x-coordinate of the point in orange is going to be 1/2, and the y-coordinate would be root 3 over 2. And, those are the main ones that we really have to know for pre-cal and calculus, but I'm going to extend this to really where the things that we need to know that we don't already know. I think you could have already told me the sine and cosine of pi over 6, pi over 4, and pi over 3 by converting them to degrees and using a triangle, which is exactly what I did. What you really need to notice here is that the x-coordinate on the unit circle represents the cosine of the angle, and the y-coordinate represents the sine of the angle. And so that's where I'm going to extend this to the discussion of 90 degrees, 0 degrees, 180 degrees, 360 degrees. Okay, so let's talk about pi over 2. Okay, and then pink up at the top of the unit circle. We know the coordinates of that point because this is a circle with radius 1. So if it's on the y-axis and it's on the circle centered at the origin, radius 1, x-coordinate is going to be 0, y-coordinate is going to be 1. And as a result, I can say that, okay, well, cosine of pi over 2 is the x-coordinate, or cosine of 90 degrees, and that's going to equal 0. And the sine is the y-coordinate, sine of pi over 2, sine of 90 degrees, that's going to equal 1. In the same way, I can notice that the coordinates of the point on the unit circle that correspond to theta equals pi is going to be where x is -1 and y is 0, because I'm at the left edge of a circle that's centered at the origin with radius 1. It's on the x-axis, so the y-coordinate is going to be 0. It's 1 unit away to the left of the y-axis, that's x equals -1. So I could say that, cosine of pi, that's the x-coordinate, that's -1. And sine of pi, or sine of 180, okay, that's the y-coordinate, that's going to be 0. And in conclusion, I'm going to go back to the point in red, the place where we started. That was theta equals 0, but we also saw that was the same as theta equals 2 pi. Okay? If we asked for cosine of 0, I guess I didn't really do a very good job of labeling the coordinates at this point. Theta equals 0, theta equals 2 pi. This is the point where x is 1 and y is 0, although it was kind of labeled. So cosine of theta is the x-coordinate, that's going to be 1. Sine of theta, which is 0, that's going to be 0, the y-coordinate. But I can say the same thing about 2 pi. Okay, I guess I started with cosine, so I should do that again. Cosine of 2 pi is the x-coordinate at that point, that's 1. And sine of 2 pi, that's the y-coordinate, that's 0. Okay, now, in a standard pre-cal class, what you would do is, kind of start with these, but then kind of reflect across the y-axis and reflect across the x-axis, and end up with something about like this. But, I think that this is the type of thing that we can work on next year in pre-cal, and for now, just you having seen this, I feel really good about that. I'm glad that you've seen it at least once before you go and, get shown this and get assigned some homework problems on it. Okay, so that's going to be all for this video. That's all for this kind of series on trigonometry, and I guess for that matter, that's all for this Algebra 2 course. I really appreciate you watching and tuning in and keeping up with me on these videos, and I hope they were helpful. So thank you.